Sounds good. All right, we are recording. This is the GIST Council for October 1st, 2020. And the topic today is on what we call SemOps, which is DevOps for semantic systems. So not focusing directly on just this session. However, as we've already mentioned, many of us use GIST, and many of us are using it more and more in production type architectures. So we felt this topic is relevant as this ontology stuff moves more into the realm of the software world and production systems. So I didn't get to talk about myself, but I'm an ontologist and software architect and developer. I work at Semantic Arts now. I use GIST or a derivative daily. In fact, I am working also at Morgan right now on their purchased version that came out of GIST 8. I have decades of experience designing and building data-centric systems. Even pre-ontology, I seem to get into data federation and things like that very early on. And then got exposed to the semantic web in 2004 by actually a customer of mine in the Air Force who said, "You ever heard of these things called ontologies?" And I was like, "Nope." And kind of got started with that, started making ontologies as data layers over actual data and virtualizing the data, even back in the early 2000s. And I've built very large scale RDF applications up in the billions of triples. Quite a few years back now, probably 5 years back, we were doing that, integrating it with NLP, natural language processing. So anyway, I've been an invited speaker at one or another conferences since 2009. I met Dave that way and the Semantic Arts team, and happy to be a member of them now. So let's get to what we're going to talk about. We're going to kind of couch this as, first off, what is DevOps? Because I don't know if everyone on the call is a developer. A lot of times ontologists aren't necessarily in the development area. But again, we're starting to see more and more of a merge of that. So we'll talk about what DevOps is. It's a pretty well-defined practice, and then what SemOps might be if we kind of make that leap. I'll kind of go into a roadmap then of kind of what feels like a roadmap of how would you get to SemOps, and some tidbits on where we are as an organization along that road. We'll talk about existing tooling that exists, for doing this sort of thing. I'll show you some demonstrations of that tooling, and then we'll have some Q&A. So let's get going. So first off, what is DevOps? And DevOps is defined as a set of practices that combines software development, that's the dev part, and information technology operations, that's the ops part. And it aims to shorten the systems development lifecycle and provide continuous delivery with high software quality. That's kind of the Wikipedia definition. I think it's a pretty good definition. Folks from the Software Engineering Institute and others defined it as a set of practices intended to reduce the time between committing a change to the system and the change being placed into normal production while ensuring high quality. Okay. So that's kind of what the goal of it is. And then, so what are the key elements that kind of help achieve that goal? Well, there's source control of software versions, very important. Many of us are exposed to things like GitLab, GitHub, Bitbucket, things like that. So we need to source control the software versions. Can't have them just sitting on some dev's computer. Automated build and regression test of software versions. Okay, so that means the ability to kind of push a button and have the software versions, either candidates or the production versions, be able to be built, run through a set of tests to make sure nothing's broken. That's the automated regression test part. Again, most systems I've dealt with in production, are completely built around this now. Automated regression tests seem to come in. It feels like 10 years ago, so it's probably more by now, but this idea of, say, JUnit tests and things like that. Automated deployment of the software version. So the idea is you want to, instead of having someone have to get on the keyboard and clickety-click to build things and test them, you want all that to be be able to push a button, have it happen, have the same test run every time, make sure you didn't break something that used to work. assuming things pass the test, you move to automated deployment. So then how do you start to stage that working software, that unbroken software, and put it, say, into a staging environment? Maybe it goes from the development environment of the software guys into a QA environment, then into a staging environment, then into a production environment. And again, all that is getting automated these days. And then there's the idea of continuous monitoring. So this is once you automatically deploy a system, how do you kind of keep checking on its health, make sure it's running well, make sure it's, not dropping connections or having different, types of errors. And so there are tools for all these things, often called tool chains. So DevOps has this whole set of tool chains. Tools have developed, again, over the last decade or so to fill all these areas. So going back to those areas again, source control, again, Git, GitHub, Gitflow. These tools have online code review where you can do something called a pull request. You'd like to get your change in. You can nominate people to look at it. They can comment on it, make suggested changes. You can, fix it, do new commits, but essentially lets you review things in a distributed fashion, in an asynchronous fashion. There's automated build and regression test. Systems build and test on code check-in. Often they'll run the tests, and if the tests don't pass, they won't even let you commit a new source version. There are unit test frameworks. Unit test simply means, software is broken down into smaller and smaller components. We get down to small units. We can test them individually, make sure they work. Developers can write a little test that makes sure that this particular widget or this particular function handles a lot of edge cases. And then those just get run every time you run the automated test framework, which again can be based on code check-in. JUnit is one for Java, PyTest is one for Python. Pretty much almost every language now has this ability to code and run automated unit test frameworks. And again, the primary goal is regression testing. Yes, you added a new feature, but did you break something in the system? These unit tests will grow to hundreds or thousands or tens of thousands of tests across a code base over time. And certainly it's way better to, as I say, let the robots do the work, let all that tests happen automatically instead of counting on some human every time you change things to click every button and make sure, things still work. It's not practical in the modern world. And that's why these frameworks exist. In addition, there's automated packaging tools, tools that will package systems for deployment. They will check dependencies. They will pull in needed libraries, things like that, based on strict versioning and build a version of the software that's ready to run or deploy. And then once you've built that system that's ready to deploy, there's tools. You'll hear the word CI, which is continuous integration. These are either fully automatic or human in the loop. That's what the HIL is, human in the loop, to deploy to different environments. In my experience, deployment to dev or a development environment might be automatic, as well as a test. A lot of times staging and production environments, these tools can have human in the loop, little buttons that you look at in dashboards and you say, yep, it got through this, I'm willing to push the button and move it to the staging environment, etc. So there are tools to do that sort of thing. Continuous monitoring, there are multiple tools for that. I mentioned Sentry here as one of them, but there are certainly others. And again, this gets to where you're actually monitoring your runtime environment and seeing how things go. There's even cases, I know, Amazon and a lot of the bigger organizations will take a change and they'll push it out to about 5% of their clusters and they'll let that change run. So the newer version is on some of the software, but not all the software, and they'll check it for errors and problems. And if it's going okay, they'll move that to 10%. They'll essentially be rolling forward of versions. Ultimately, if something doesn't break and they have to roll it back, then you'll be fully running on the new software after a little while as it slowly propagates through all the servers. Okay, so that's a background of kind of where DevOps is today. And the next thing would be then to ponder, and Dave kind of was asking this question to our team late last year. So what might SemOps be, as we get more into production environments with customers, and we're not just creating ontologies and handing them to someone and not sure what they're going to do with them, but we're integrating data, we're changing ontologies faster. What might SemOps be so that we can get these changes in? So to quote Dave from that Dave, he says, SemOp is both a methodology and tools that will allow an ontologist to push a change into production in the least amount of time with little risk. It would involve detecting which changes are likely to have adverse impacts and testing. Okay, so same idea now on the ontology side, right? And we'll dig into kind of all the aspects of that as we keep going. I found it interesting that if I took the same DevOps statement from the SEI, it still seems to hold true, right? A set of practices intended to reduce the time between committing a change to a system, in our case, a change maybe to the ontology, to the schema, and that change being placed into normal production while ensuring high quality. I mentioned the ontology. I mean, it could be queries and other things too, but certainly the ontology as the core language of all of the integration, the whole idea of getting things down to a small model means that that's probably the biggest change. If you change the ontology, you've got to think about all the places that could impact things and make sure you don't break anything, bottom line. So I think, we think for ontologies and semantic web, what does that mean? Well, source control of ontology versions, right? Just like others are source controlling their software, their code. So again, the same things, using Git, using GitHub, Gitflow, online code review, Bitbucket. And I would say Gist, getting back to just a tiny bit, Gist is now maintained this way. I think it was always on, or it's been on GitHub for quite some time, but we've normalized our process. We've made it public. We're using issues. We're using kind of the Gitflow standard source control practices, which we didn't used to do. In fact, probably only about 2 or 3 years ago, Gist was maintained in a Visio file, which is a binary file like Word, and therefore can't really be checked for differences very easily. And that was fine when Michael and Dave were the primary developers. But as we got a team of 10 or more ontologists, all suggesting changes and making changes, we definitely needed to go to a more distributed, rigorous, and industry standard way of source controlling the ontology. We're using, this sort of thing, what we're doing in Gist and just SemOps in general needs a more precise understanding of versioning. So we've adopted something called semantic versioning. If you were to look at semver.org, you'll see this. It's really just a way of having semantics in the meaning of the version positions. Like much software is versioned with like a 3 position, like a 1.2.3. And so the question is, what does it mean to change the highest number, the first number versus the middle number versus the last number? Semantic versioning defines those things. Generally, the major version is not backward compatible. The middle version is additive, but still backward compatible. And the last position is like a bug fix that doesn't really add or change any features. It just fixes a bug. Again, that sort of thing, being precise about what you mean in those versions not only helps people who see new revisions coming out, as revisions come out more often, they can understand, oh, this is just a bug fix, or this must added features, or, oh, I can't use this with my old version, depending on how you number things. So we feel that that's very important, and we've adopted that. Going to the future, I'm not sure. Yeah, I guess I think Jamie's on the call, but one of the things that we've been talking about is, what about when you get past files? So at least, especially ontologies where the ontology can live and ultimately does live in the triple store. Right now we tend to have this artifact of a file or multiple files that define the ontology. But SemOps will come to mean, quite possibly in the future, in triple store change management with no files. So you'll be tracking individual axiom changes. we think there's actually a lot of value to that, because if the ontology is in the store, as well as the Sparkle queries, the shackle shapes, again, you can kind of analyze all these things together and understand impacts pretty well. So that's kind of future looking. I don't think we're doing that yet. Jamie, if you want to comment real quick on where this is, feel free.
You're correct. We aren't doing it yet, but we are working towards it.
Okay, very good. Thanks.
Some of the triple store vendors have some pretty good, like Cambridge Semantics and Top Quadrant have, the diffs, and they have the trees just like Git. You can see the merges occur, and so
Nice.
I think they're showing the way now.
And I think it's Flurry, but there's one of the systems out there that is doing. They talk about distributed version control, not just of the ontology, but of entire graphs. Is that Flurry? I think it is. Anyway, yeah. So we and others are moving in this direction. Okay, so that's kind of the source control part. What about the automated build and regression test? That sort of thing would apply then to automated build and regression test of ontology versions. If you change the ontology, did you break some reasoning or some other feature that you didn't mean to break? Did you make it logically inconsistent? These are things that, again, people might be doing by hand if they're conscientious in their, say, Protege or whatever their tool is. Run the reasoner, make sure it's logically consistent. But again, as things, if you're counting on people to kind of point and click and do the testing, you generally don't get great coverage, and quite often you miss things. So in the world of SemOps, this would mean automated consistency and regression tests, testing the inferences, maybe testing existing queries, especially if you have a query library that APIs use. This would be not only T-box, but A-box testing. In other words, testing your reasoning of T-box only, which some people do, just the concepts, but not data. And you can also be testing kind of like unit tests do. Take your ontology with a small amount of data that should have a certain either success or failure, and verify that the test discovers that success or failure as expected. The other, part of that automated build and regression test is the idea of lint checking. Lint is a term that came back out of C programming way back in the day, but it's, it's just checking for either stylistic problems or code that's unreachable, things like that. Things that are kind of dirty and need to be picked out of the code to make it cleaner. In the semantic world, this can mean missing labels, checking to make sure you've got maybe labels and other required annotations based on your style guide. You might not want an ontology to go out in the wild without, say, a SCOS pref label and a SCOS definition, things like that. Again, as we move to more and more things like using shackle against the ontology, you might have a lint checker that's looking for concepts that don't have any shackle shapes associated with them. A lint checker also in a more unified system, again, as like we're working toward with the data-centric architecture where everything's in the triple store, including your queries. A lint checker may be able to check that the way you've changed the ontology is no longer conducive with certain queries that are using the old terms, for example. So all that would be part of this automated regression test of ontology versions. And lastly, automated packaging, right? Like a lot of things you want it to build, like, in the code world, you maybe compile code into binaries or, class files, jar files, things like that. Automated packaging in the ontology world might mean merging in, maybe you keep an ontology separated as multiple source files for ease of edit or for some other reason, but you kind of want to provide a single unified ontology on the way out. It's nice to not have to have people doing that manually and error prone. Sometimes you want to make sure you're punching in the right version number as you release things. You want to make sure the annotations are complete. Maybe we'll get to this maybe a little later. We talk about, some people use RDFS define by to say where a concept comes from, but it's kind of tedious. You just want it on every concept in there, so it's kind of tedious for a human to go in there and hand put that in on all the concepts and make sure they're there. Automating that is nice, and that's something we've done. Automating release note generation off of, say, GitHub commits is another idea that you might do. Okay, so, and as we move forward, that was the automated packaging. What about deployment? Automating the, deployment of new ontology versions through a dev, test, staging, and production environment, just like software, is something that SemOps would cover. I call this shackle synchronous deploy. I mean, the idea is if you want to deploy things, again, if you've changed your ontology, you certainly would need your ontology and your shackle. I think everyone knows what shackle is. It's the shapes constraint language. It allows you to say what your knowledge graph should look like as it uses bits from the ontology. It often goes beyond the OWL restrictions because it can do some things that OWL restrictions can't. Plus, not everyone's running inference in their runtime environment, but shackle's not asking you to. You need that for the OWL constraint validation, but you wouldn't need that for shackle. It does it its own way. But the idea of synchronous deploy now, you got to make sure that you're not going to put one version of the ontology out with a version of shackle that isn't conformant with it, or you'll get shackle errors. So again, automating that part of the deployment. Not to mention knowledge graph conformance to the new ontology version. So if you've got existing data and now you change the ontology a bit, you've decided that there's a different property that should be used, or property name changed, or something like that. You've got to make sure that the actual data it will now conform to the new ontology. So all that kind of alignment has to happen. And again, it can be very difficult if people have to just go through and make sure they hope they caught everything. So we'd want to automate that sort of conformance and synchronization. And this is, part of that is, potentially transforming the data. So as you put in an ontology that, let's say, changed a property name, you want to do Sparkle updates that will conform the graph to be able to use that new ontology with the new property names. Also, if you, one case you may have existing graph that you want to go in and change in situ, in its place. The other thing is you may actually not be doing things that way. You may be doing data generation, where you have ETL scripts, export, transform, and load scripts that are pulling from a system, doing a data generation, and then ingesting that data as a batch. But there again, same issue. You want that data generation, those data generation scripts or transform scripts to start conforming to the change in the ontology version. So you again want to synchronize all that. Or you may be doing data virtualization. We're using an R2RML type engine, something that's going to on the fly be virtualizing queries, reaching into systems. Those tend to have mappings. R2RML is like kind of the standard language for those kind of mappings, but there are also proprietary ones. There again, if you're changing the ontology, essentially changing the schema, you need to make sure your virtualization mappings are in sync so that if you deploy the new ontology, the data is virtualized, conform it with the new ontology. Sparkle queries, as we may have mentioned before, may have changed. So I think in the previous one, as you're building and testing, you want to make sure you catch them so that you can change them. When you get to this deployment step, you're looking to make sure that everything is synchronized in the deployment, that the Sparkle query changes come at the same time as the ontology changes, so everything hangs together and you don't get errors. And last off, continuous monitoring. Probably, again, you could probably use some of the standard DevOps tools. Where you're just looking for errors, you're looking for server errors on your, let's say, your triple store engine. You want to see if it's getting lots of errors or dropping connections, things like that. Shackle in some ways continuous monitoring. If you start to see more and more errors in the shapes, right? You're starting to see things that don't conform to your shapes. Maybe you had you missynchronized things. But the bottom line is that all of these elements that were in DevOps, I think, can apply to SemOps pretty much one for one. It's just a slight difference in focus. I would say also, I guess along those lines, that as we kind of talked about, part of the beauty of going with this semantic approach is that you are using your logical model or conceptual model for everything. So in some ways, it may be even more important, because in software, a lot of times you have little functions and things like that that are pretty contained and not, you don't have to worry that the whole system's dependent on that. But when you change an ontology in a data-centric system, it's very central. And because we're trying to keep everything down to a small vocabulary, I think the chances are that most changes that have a fairly far reach. And so the SemOps is very important. Right, query performance monitoring is the last bit here, I think, or another bit of monitoring you want to do. Maybe something you change in your ontology is affecting your query performance. I think most systems, modern systems, would give you ways to look at this, but it's something you're going to want to look at. And the idea of automated rollback, which a lot of these DevOps systems have, right? The idea that if you're monitoring and something is going wrong, you need the ability to roll back to the previous version while you figure out what's wrong with the new version. So again, I've mentioned some production systems have this way of doing kind of a slow deployment of a 5%, 10% in at least like a cluster environment. This would depend on your environment. But they kind of allow that. Let's try it a little. Let's see if we're getting a lot of errors. It's looking pretty good. Let's go a little more. But in all these systems, if there's a problem, then they want to be able to roll those clusters and servers back to the previous version so they can fix whatever's not working in the new version. Okay, let's see, just checking time. I promised a roadmap. It's really just the main things we talked about. If your roadmap is, I think in general, you're kind of going from left to right in terms of, first, you should be doing source control, even if you don't have any of this other stuff happening. You should definitely be controlling your ontology and making sure you know what the current version is, what the released version is, that you don't ever lose it, and that you are doing disciplined changes to it. Then I think you move to automated test and packaging. This is something we've seen at Semantic Arts as well. So yeah, I can control it, at least know what the version is, but maybe I have to do a lot of handwork to get it ready to share with people. Or I don't have any sort of testing to make sure I didn't break anything. I think that comes next. These automated deployment and continuous monitoring, really in the realms of, are you now in a, I think these are good for anyone developing an ontology, even if they just post it to the web and say, hey, go ahead and use it. These automated deployment continuous monitoring come in, when you're starting to use it in production environments within, your organization or with clients that you're working for. I'll kind of tell you where we're at. At Semantic Arts, like I mentioned, we've been using GitHub and things like that for a while, but again, the code was in some ways in a binary artifact, and so in early 2019, we kind of moved it fully onto GitHub as source files, no longer in Visio. And we moved to something called GitFlow, which is kind of allows multiple threads of feature development to happen simultaneously. We now use online code review, etc. In very early 2020, we moved to automated. We actually had something in 2019 for automated packaging. It was kind of a Windows script. We've made that more sophisticated now. I'll talk about that in a little bit, but our own Boris Pellick developed an ontology toolkit that keeps growing. And in 2020, very early 2020, we shifted to using that for our GIST automated packaging. And this had to do with stamping versions into GIST, merging GIST when it was multiple files into one file, building it now, we've shifted to providing RDF-XML, Turtle, and JSON LD versions of the files. We put in release notes and licenses. All that now is something that essentially you run a script an error in trying to pull that together, or a lot of human variation. What's in the future for Semantic Arts, as we talked about with Jamie, a little bit of this idea of in-store or in triple store change management. That's something that we are working toward, as he mentioned. Automated test and packaging is probably happening at various levels with us and our clients. I wouldn't say it's not on GIST right now, But the idea was certainly all of us by test for logical consistency, hopefully in our protege or tool. But I'd say this is still somewhat piecemeal for semantic arts. Some of us are using these in some places, but I wouldn't say it's consistent across the whole firm. And I'll talk about some of these in a second. I'll demonstrate some of them. Automated deployment and continuous monitoring, I think, are still future for semantic arts. Though I will say at one client I'm working at, we are just in the process of automated publishing of ontologies. We're probably got into that just in the last month or so. They're standardizing how that's done, and then essentially once we check something into the source control system, ready for release, the robots will take it from there and automatically publish it using the Widoko tool onto websites and things like that, as far as I know. So we will get out of having to do that by hand, which I'm looking forward to. It'll keep it very consistent no matter who's, what personnel comes and goes. Okay, let's talk about existing tooling. This all sounds great. Like, is any of this out there yet? So I want to tell you about a tool called Robot. Robot is a tool that came out and was put on GitHub in 2019. They call it a tool for automating ontology workflows. There's a paper on it. There's a link there. I'm sure we'll make this deck available. There's some documentation out there on the web. It is available on GitHub. There's tutorials for it. I'll show you a bit of what how we've used it, but it's kind of a script for a command line tool for doing a lot of ontology workflows. And command line may seem archaic to some, but command line tools are actually super important still, because those are the ones that are automatable, that you can put scripts into a continuous integration system and it can run it. You don't want those systems having to deal with a graphical UI. So these are tools that allow you to define multiple tasks in a row, what we call a pipeline, to kind of do multiple different tasks you might want to do on ontologies. Jenna has been out there for a long time. It's in Apache, Jenna. It's been out there since 2006 or something. I've been using it the whole time I've been messing around in the semantic web. Not a lot of people use it to write code, like they use the Java libraries, but it has a set of command line tools that come with it, and I've made use of those and expanded those as I've worked with it. I use it for Sparkle lint checks. You can use Sparkle queries for these lint checks, like checking for missing labels and annotations and things like that. You can also use it for unit testing, and I'll show you, this is not standard tooling, but using the Jenna tooling, I have created a unit test framework, which is very simple, and but I'll show you how that works. And hopefully more tooling will come out in this area, and it might be out there. Maybe we'll have a chance to talk about that in the last few minutes. Also, new since I presented this back in February, there's the Ontology Toolkit is something available on GitHub that was created by our own Boris Pelek, initially and mostly for internal use in packaging our ontologies, just for production or for distribution, I mean. But Boris decided, why not put it out there and put it in the open source world, and if other people can use it, have at it. It is growing all the time in its functionality, but it's good for automating the update of ontology, meaning version numbers, automatically putting in RDFS defined by, instead of all trying to do that tediously by yourself. Merging multiple ontologies into one, which up until about just 9.3, we were maintaining between 16 and 19 files, and we wanted to distribute it sometimes as a single file. Other packaging, like packaging ontologies for releases. This means, and I mentioned with GIST, we use this for generation of multiple formats. We edit in one format, but we create a release package that has multiple formats. It can create the release folder structure, put release notes here, put deprecated bits there, put diagrams here and there. So it allows us to package things. It also allows you to actually create graphical depictions of ontology imports, though after we developed this, because we were doing GIST in 16 to 19 modules, we recently demodularized gist because it's a pretty small ontology. So we're not using the graphical depiction too much on gist anymore to show its imports because there really aren't any. But you can still use it for other ontologies where you need to understand the imports. Fibo is a good example that has a whole bunch. Okay, demonstrations. Some of this I'm not going to take the time to demonstrate because I don't have a ton of time, but I'll demonstrate some of this. So first off, let's just talk about de-linting. This is, and none of this is rocket science, by the way, and you'll see that. So de-linting, again, you can just execute Sparkle queries to find things like missing annotations, for example. This is an example of a lint query that's saying, I'm going to look for non-blank nodes, since ontologies use a lot of blank nodes. Usually those are defined or named entities. So anything that's not a blank node, that is one of these OWL types, object property, data property, annotation property, or class. Find ones where there doesn't exist both a label and a comment, and tell me about it. And if you run this, this is just a little command line. SP is short for Sparkle, which is just a alias for running the Jenna Sparkle tool. It's going to run, here's your ontology. Let's say I have an ontology called ship ontology, and I have this lint query, which is just this query right here. I run it, and it's just going to show me, okay, you have these three things that that are missing. You don't have both a label and a comment. So you can customize your lint script all you want. You may want to use SCOS label and SCOS definition. You may say, I only want a lint for labels. Definitions aren't required. Things like that. So, but this is just a very simple example. If you can put it into a command line, that means you can run this sort of thing just as one of your checklists before you check in an ontology, or you could run it in your pipeline. And you might even say, I'm not allowed to check in a ontology that is missing annotations. So that's an example of de-linting.
I've got to bail out.
Yeah. Oh, okay.
Yeah, I wanted to say I had thought and kind of hoped that this would be about the applications of ontologies to DevOps rather than the other way around.
Oh.
So you might want to think about that idea.
Yeah. Onto for DevOps. Got it. Sorry to disappoint.
Yeah, that's all right. It was still very interesting.
Okay.
Hey, and Mark, on that last slide,
Yep.
if you were using that in your move to production pipeline, would you write the query differently and just have a count and have the thing test for a count greater than 0, or?
Yeah, or maybe just have an ask query, and if it fails the ask, don't go. And that's how I do the unit tests, actually. Yeah, this is more for me manually, so I want to actually see what they are so I can go fix them.
Right.
But yeah.
Quick response to, I forgot who that was who asked the question, but we are actually doing some stuff at the moment with one of our clients to use an extension of GIST for versioning for doing dependency tracking, and that's a little bit more along the lines that they said, but that's still in the works.
Like Onto for DevOps?
Yeah. So
cool.
just a little heads up, we're doing something along those lines, and we'll be releasing that before too long.
Oh, cool. Again, the robot tool. One of the nice things about it is it's got a command line version to run a reasoner, and I tried running this on this little ship ontology that I kind of purposely made a problem in, and it tells you again, there's an unsatisfiable property in this ontology, and again, if you kind of run this as part of your checks before you check things in, you can go, oh, oops, I've made my ontology kind of inconsistent. There are other tools beyond just a robot, but robot's out there, it's freely available, and I think this was a nice feature of it. I could go back in and fix that problem. And then here's the idea of automated regression tests. I created a simple unit test tool. Again, I kind of hope they'll come out with one, and if someone may be able to correct me and tell me that between the time I first wrote this in February that they are. But regression tests are not that hard conceptually. As an idea of unit test, basically you just want to have a function, if you will, a small amount of data, and you just check to see if when you kind of run the test, you get what you expect. So the way this regression test tool works is it basically just combines, and I'll actually show you the tool because it's just a script I wrote. I guess it's a little hard to read, and my mouse is giving me fits. But so this is just a script I wrote. All it does is it basically takes the ontology that I'm working with and combines it with some data. So the idea is you'd have a directory where you have multiple tests. This is the way tests usually work. In this case, you see them named as test, infer location transitivity, test, infer oil tanker, test, person subproperty, subparty. All this means is there's a convention that says if it starts with test and ends with RQ, then I will run it against the ontology plus the sample data. I'll put it all together, I'll infer it, and then I'll verify that all the tests work. This is the way a lot of these frameworks work, where there's some convention for naming tests, and all the tests are trying to do is get what they expect. If they don't get what they expect, they tell you, and that you know you've broken something. In this case, as I mentioned a little bit earlier, Dave, I'm just using a Sparkle Ask query, and the idea is that the convention is everything in the directory that's named test should run against the combined data and ontology with inference, and should always return a yes. So a no indicates a failed test. Let me show you, let's see. So forgive me. Here's a directory that I have. It's got this run test bat script in it. It's got a test data file in it. It's going to reach up to the ontology directory, pull down the ontology, combine it with the test data, run inference on it, and then it's just going to go through, and for everything it sees it's a test.rq, it's going to run it. If I do this, it'll run through each of those three tests. You see it's currently running inference and combining the data, and it'll run the ask queries. And in this case, they are all going to work. If, for example, that infer transitivity test, if I were to come here and actually change this ontology. So the point is, in the test data, this is just saying in the test data, or when the test data runs, I'm expecting Jefferson County to be located in Texas and the USA through transitivity. The data just looks like it's just a little OWL file that has some instances. So the whole point is, if you combine this data of instances with the ontology, I would expect to get that Jefferson County is located in the United States, and that's all the ask query is asking. Now that I've taken out transitivity, that's probably not going to happen. And you'll notice I get an ask no. So the point is that the location transitivity test failed. The oil tank infers something to be an oil tanker, still worked, etc. So you don't have to know the details of the test. Those are the things you do specifically with your ontology and with your data. So that's what developers do. They write these little tests that say, given all these inputs, this is what I would expect, and this would allow me, if I accidentally fat fingered and made this non-transitive, for example, that inference breaks. So that's just the idea of a regression test framework. They're not that hard to write, but it would be nice if a more standard one comes available. But until then, feel enabled to write your own. They're not that hard. You just need a command line reasoner, like Robot has, and a little bit of data and a convention, and off you go. I mentioned automated packaging. I'm going to skip this slide real quick, but Robot allows you to, for example, run a pipeline where you can, do a merge command followed by an annotate command, push in new URIs for things, set up new annotations, etc., and output. So the point is you can invoke this on a command line and get it to work. More recently, our ontology toolkit has been developed, and again, it's publicly available. It's got subcommands. In other words, the main things you can do with the toolkit: update, export, bundle, and graphic. So for example, here's just a few examples. We use the Onto tool. I can say, hey, I want you to run an update on JISC core, and I want you to put in all the RDFS defined bys in there because they're not in there. Let's see, whoops. Here's another one where we actually say we want to use the tool to bundle things for export. I am going to show you this real quick. Whoops. because even though I know we're low on time. Here's a grep of just core for RDFS defined bys. There are none. But if I run the update and say put in defined by on just core, this tool is going to go in, essentially find all the things you've defined. And this is just putting on the output, but you'll see that what it's done is now it's gone in and it's figured out I should put this RDFS defined by, and it's using the ontology URI of the ontology. Simple, but gosh, doing that by hand is a pain. And lastly, we use this tool to bundle, meaning I'll try and show you this real quick as well.
You're out of time.
Out of time. Sorry about that, people. Anyway, you don't have to see it all. It's a tool that you can look on GitHub to see, and it's got a script that you can set up that essentially lets you chain a bunch of things. Like I would like you to first go put in this version number, and then I would like you to put in defined bys, and then I would like you to build a distribution folder with this name, and then I would like you to convert this file from XML to Turtle and put it in that folder, et cetera, et cetera. So that's basically how that works. I'm sorry I didn't have as much time, but I will stop here and thank you for your attention. And I'm okay to stay on, but I don't know, Dave, if we have a policy to drop things right at the hour.
No, if people can stay. Actually, I had 3 comments I wanted to make, but I'll leave them if anybody else has something brief they want to say.
This is great. I intend to leverage some of what you've done here in the upcoming presentation I have. I should probably follow up with you and talk about that. Get a chance. I'll send you an email.
Okay, great.
And I just wanted to say that because we do use the ontology tool to package gist, there is in the gist Git repository, there is a bundle configuration file, and it is sort of internally documented. You can see what it does and use that as an example. Also, the gist repo links to the GitHub repo for the ontology tool, and it has extensive documentation over there of the things that you can do with it.
Awesome.
Okay, so here's my 3, and I'll pause in between each of them so people can comment on them. The first one is: do you think the scope of SemOps should include detecting changes in source schemas? Because, if we've got R2RML and, Tarkle and stuff, you discussed, we changed the ontology, obviously they may be affected, but actually we're probably more victim to somebody changing the schema of the source file.
It's certainly affected by that. I guess it might depend on what sort of insight you get to those changes, right? I mean, it sounds great if you can do it. I think it might depend on the tool as to whether or not you can.
And you may need to poll, source systems periodically. If you can detect, I don't know.
And if you couldn't, that whole step of continuous monitoring. I mean, if you attempt to deploy and everything was clean on your ontology side, and hopefully you've already staged to a test environment and other things, and you would have caught it. But let's say you didn't. That continuous monitoring should start to determine, wait, you're having a lot of errors accessing this data. In which case, I was going to say, I mean, theoretically, the fix is usually to roll back. Now, the point is, you might say, but I didn't do anything wrong. There's nothing wrong with the ontology, but the point is your mapping scripts are out of sync. And so you are going to need to roll back in some way, assuming those were synchronized. I guess the other thing is if they just change it on you, period, you're not going to know. But or unless you can find a way to monitor those systems, but you would obviously start to detect errors, I think, in your virtual translations.
Yeah, this is Jim. We have some metadata management tools that we use to detect those kinds of things. But
nice.
What would be helpful, I think, would be to provide some sort of an impact on the ontology itself, and kind of help direct you to where the problems could be.
Yeah. And in fact, that's almost exactly my second comment. Maybe we want to split out that automated deployment chevron into something, maybe I'd call it impact analysis, but you almost literally have to do a triage at that point and say, can I predict based on the nature of the change, one of three things? Well, not partly in the nature of the change and partly in the nature of the target. The first is, can I predict that there's going to be no adverse impact possible? I've just added a comment or I've done something.
Yeah.
Should just go straight through. The second one, you have to look at the target. So you have to know, and is my target a dev? Because we have this possibility that you could have one ontology and many repositories. Maybe you've got an uncurated and a curated one, and you may literally want to look and say, this change, there's possible impact, but sort of like you described there, I can look at the sparkle, I can look at the shackle. There was a possible impact, but this target escaped impact, but this other one, uh-oh. And then the third part of the triage is, we need to actually change something in the target. And that's where you get into that thing you said, you have to have a script to change the data or do something else.
Yeah.
And then my last is just an off-the-wall thing, because I've been rethinking the semantic arts ontologies. And you would think that we'd be safe. We're mostly talking about T-box changes here. So you're sitting there in the database and you change some data and you think, well, I don't have to have DevOps if I'm just changing data. But the edge case, the really weird one, and I haven't totally figured out how to deal with this yet, is certain CBOX data. So in CBOX, you've got a small taxonomy. Many of them are designed so that people should be able to just use data entry and add a tag in a CBOX, and it shouldn't really break anything.
Right.
Once in a while, we use CBOX values in queries. For instance, in the semantic arts, the way an employee is active or inactive is a CBOX distinction. But you could easily imagine exempt versus non. There's a handful, and maybe we have to separately designate or detect by looking at queries or something that CBOX changes that could have adverse effects.
Yeah. Let me just comment there, Dave. In actual fact, there can be software applications that depend on data. And so if you regenerate a data set because the T-box changed, you might think that you don't have to worry about the data changing, but in fact you do. And that's one of the things we're doing. We're tracking the dependencies between applications that use a generated data set, which might change. So some of those dependencies need to be tracked, even at the A-box level.
Yeah, and my, Dave, to me, the tracking those ontology changes would definitely include the CBOX for sure. Any impacts, and again, the query analysis and synchronization, possibly even the shackle, right? You can call out values in shackle. So I include CBOX as the same first class citizen as A-box, though, it's T-box. But it is interesting because, we kind of developed the CBOX idea. We have other reasons, but one of the benefits is the idea of governing it separately, because it's less likely to break the ontology in terms of axioms, which I think is true. But certainly, when it comes to the SemOps, it certainly has the potential to break the overall picture, which is ontology and data and queries and shackle. So yeah, you definitely have to keep an eye on that. And again, that might be under different governance. So it's that same kind of thing you talked about detecting. Like, as the ontologists, we didn't detect that because some other group changed the CBOX on us. But we have to be able to know when that new CBOX is trying to get deployed. Sooner or later, they'd have to publish that and get it involved in the overall ecosystem, at which point we'd want to do those impact analyses and see what queries does that touch, what axioms does that touch, et cetera.
Yep.
Yeah.
Dave, the impact analysis that you were talking about, does bring up that whole thing of the distinction in the automated deployment. Maybe you have to alert everybody who might be impacted, particularly with those queries of which you may not be aware, or those application things, that could trigger, where you have to have the package ready to go, but you have to wait until there's some sort of consensus before, doing any sort of.
Yeah, but I think we want to start moving toward being able to detect those things that we can't currently detect. Like, we should be able to parse a query and know that it refers to this class or this instance, and therefore be able to know whether that repo is going to be impacted or not.
Yeah, well, Dan's talking about the application-centric world. So if we can get everybody in the world to move to data-centric, then yeah, we can address that.
Right.
But until that shining day, you have to, make an allowance for the people who have their queries off in some file of which you are unaware.
Yep.
Mark?
Yeah. And in that environment, I suppose you just send them a notification to say, look, by the way, these things have changed. Your mileage may vary.
Yeah, if you know who they are, and again, there's a certain amount of monitoring. You could do connection monitoring to see who's even talking to the triple store. In a non-DCA environment, you could attempt to be aware of who's using the system, but it doesn't seem foolproof to me, or that you're going to always get a great answer. You might get some IP address, but who really owns that? That could still be difficult. I think someone was trying to ask a question.
Yeah, it's something kind of different. You said you're not making DevOps in the triple store at the beginning, and everything you presented is based on Spark queries, are there? Every test you presented is like.
The tests were based on two things really: inference, and then just an ask query. That's expectation is it'll return a yes or true.
So I never implemented any DevOps pipeline, but what I don't understand is where would it block? Because you can run Spark queries on the triple store, and some triple store have this inference engine that does inference. So do you have an example where it would block in the pipeline?
Where it would block the pipeline? I guess what I'm saying is, if you have a production triple store, production data, production queries, and the kind of unit tests I'm thinking of are ones where you're suggesting a change. So you'd have some sample data. This is all on the development side of the ontology, where you have this pool of constantly growing small data sets and queries that have an expectation to pass. So the idea, when I say block, I guess what I'm saying is you tend to want to run these things and say, can I deploy my new version yet? And if you get any of the no's, it's just saying, no, don't deploy it yet. You better go fix something. I don't see that being a problem in the all triple store version. It's just in there you'd have the idea of I have a development triple store that kind of mirrors the production, but isn't. So I can do those same tests there. And if I get these no's, I know, I better not move it to QA or staging or anything else because I've still got a problem. Is that what you're getting at?
So technically, if you had like a second database, development database that is the same one as the production one, you could do everything right on your development database. Everything you presented.
Yeah, right. You're right. I mean, a lot of stuff it's kind of file based, but as you move to a triple store based one, I think as long as you have that sandbox, varying levels of sandbox, individual developer sandbox, then maybe the QA where you put it into more group testing, or you hand it off to another department. As long as you can move things along, I think these techniques would all work without the file based system.
If you look at the way, for example, GitLab does CI, it lets you get a Docker container specification that it spins up in order to run tests prior to pushing a change. So you could spin up either Stardog or a Lego graph inside that Docker container, upload your data, do some tests, run some queries, and then if you're fine with it, then you just do the commit. So you can have your verification environment be as elaborate as it needs to be without affecting any of your deployed databases.
Okay, that makes sense. Because at some point, if you get a really, really big database, files are going to get too big to process, I imagine.
Yeah.
Like, it can be harder than a triple store.
Sure, and that's why I'm suggesting unit tests at the development level generally are not like the actual production data. They're these very small units that are kind of contrived examples sometimes to test for something, right? I would picture, this idea of a dev, then a QA, then a, a test, QA, staging. As things, continue to pass tests, maybe your staging, lots of people's staging environment, or what they call pre-production, essentially is now getting access to the production data, so to speak. It's much more locked down, and the idea is it's like a sandbox, but it's going to actually see the real world, but not be the real system that customers from the outside are using. So I think as you progress, your unit test might not catch something. Maybe you'd catch it in your staging environment, which has to work on more data. But the point is, it's a progressive thing. You're trying to catch things with the least amount of effort as early as possible, but you may not catch, things that are in your true live data that weren't in these little small unit test data sets. But the idea of a unit test is since it's a lot less data, they can run very quickly and help your developers have what they call a fast dev test cycle where they can see if they broke something. It doesn't mean something may not break as you get closer to the full production environment.
So it makes sense, but did you think about how do you sample your data so that they actually represent? You mean at the development stage, you don't put all the data?
Right.
So you got to sample them, but if you sample them like very badly, you can have only part of your ontology and it's not a representative one. So it would break all the time later.
It would break later. You'd catch it later down the cycle. Yeah. Usually
the feedback loop there is when something breaks downstream, you say, oh, why didn't I catch that? Let me make a unit test for that case.
Yes.
And then go back and have a unit test that would catch it.
That's exactly right.
But if you don't have the data in your development, because the goal is to catch as much as you can with the fewer data, the less data. So, but if you don't have the data, there is some unit tests you're going to develop that just never work because you just don't have the data in your development.
Yeah.
Anyway.
Yeah, I think Dave's right. It's kind of like when you actually find, people are trying to put out non-buggy software with all these techniques on the DevOps side, but sooner or later you find a bug, right? You find a bug in production. That's kind of like what Dave's saying. So what the developers do is they said, oh, I must not have been testing for that. I missed that one, but the real world would be the problem. They'll go back and they'll build as small a data set as possible that shows that problem. They'll put that back in the early testing, the unit testing. And then hopefully the goal is we will never regress on that problem again.
Right.
And so, yeah, that's kind of what Dave's saying, and I think that's the right way. That's the way it works. That's why these tests build up over time into hundreds or thousands of tests, but with small amounts of data, so that they are timely, so that developers, if tests take too long, developers will stop running them. So you do have this difference between catch early as much as you can with small, fast tests, but you do have to have this progression of slowly getting at bigger and bigger things. And then the last thing I've heard, people have what they call smoke test environments. And the smoke test environment is much more based on scale and production scale and lots of connections trying to hit. And that's not a developer thing. You don't want to take the time for that. So once you get the functional bugs out, you push into a smoke test environment, and that environment is just taking your latest software, your latest ontology, and your graph, and just beating the tar out of it production-wise. And if things start to break there, you've discovered some other issue, and you will, again, do forensics, try and figure out what broke, why is this breaking, attempt to fix it in the software, or in our case, the ontology. Put in some tests early on if you can. Some smoke test things are just strictly scale, but you know, so these environments have this idea of unit testing, staging testing, smoke testing. The more sophisticated you get, the more these different aspects of possible problems you're trying to test before you go into full production.
That makes sense. Thank you very much.
Yeah, sure. All right.
Let's call it.
Yeah, let's call it. I'm good.
Great. That was excellent. Thank you.
Thanks for your extra time, buddy, and have a good day.